All right, we're going to spend some time today going through a really important section here in Algebra 2. You can probably tell because of the word theorems right there that this is going to be pretty important. We're going to talk about two basic concepts today. What happens when you get a remainder when you do division, when you don't get a remainder when you do division, and how that relates to factors of a polynomial. So, a little review from what we've done in the past with synthetic substitution. We would take a function like this and put a value in instead of directly. We'd use this little device called synthetic substitution. So if we're asked to find f of 4, we put 4 in this box, and then we put the coefficients of our polynomial, which here happens to be a cubic 4-term polynomial, and we drop the first, and then remember we multiply everything below this line by that number in the box there, by that 4. So we're putting 4 in for x here. So we drop the 2, we multiply that 2 by 4, and we get 8. And now we always add these numbers up here, which is why we dropped the 2, because there was nothing to add it to. Negative 3 and 8 is 5. 4 times 5 is 20. And we add those together to get 24. 4 times 20 is 80. And then 4 and 4 is 16. So that adds up to give us 96. And then we add these to get 98. Okay, and then the proper way to answer this is that f of 4 equals 98, which tells us when x is 4, y is 98, or a point on the graph of this function would be 4 comma 98. Now we're going to do the same thing with negative 2. So we put negative 2 in, 2, negative 3, 4, and 2. Drop it, multiply, add them, multiply, add them together, multiply, add them together. So we know that f of negative 2 is negative 34. Because we did not get 0 when we put those values in, either one of them, we know that neither 4 nor negative 2 are zeros of the function because they do not evaluate to 0 at the end. So we're going to see how that relates to what we're doing here in a second. A little long division. So we're going to divide polynomials by other polynomials. So kind of a reminder of how long division works. We have the dividend, which for us is going to be f of x. And we're going to divide by what's called a divisor, and which is going to give us a quotient, and then we'll have a remainder as well. Okay, so here's a reminder of how we do this with numbers. Okay, little nostalgic example here. So 26 into 358. So here's how we'd write that as a fraction. 358 over 26. This means division, so we do the division here. Obviously 26 doesn't go into 3, so we look at the 35. 26 goes into 35 one time. What we do now is we multiply that 1 to the 26. Then we subtract. 35 minus 26 is 9. And hopefully remember, you drop that 8 down. Now you try to see how many times 26 goes into 98. You're going to have to do a little guessing here. I guess 3. 4 would be too much. 2 is too little. 3 times 26 is 78. So that leaves us with a remainder of 20. We know it's a remainder because we're done right there. Okay, so we have 13. And then, when you first started long division, you put a little r in front of this 20. You said remainder of 20. Then later on, you put a decimal, and you carried zeros, and you kept going, and you found the decimal answer. Somewhere in between there, you should have learned that we could write this as a mixed number. 13, and then you take this remainder, 20, and you put it over the divisor, 26. So this simplifies, obviously, to 10 over 13. We're just going to leave it like this so you can see where the numbers come from, the 13, the 20, and the 26, okay? So we have two different summary statements that we could write that. We could write that 358 over 26 simplifies or becomes 13 and 20, 26, okay? That's basically this summary statement right here, okay? The dividend divided by the divisor is equal to the quotient plus the remainder over the divisor. Okay, that's what we've written right there. Or another thing that we could write is using this summary statement. That 358 is essentially 13 times 26 plus that remainder. Those are both true statements that we could use to summarize what we just found. All right, let's try it with a polynomial here. Okay, and hopefully you see the connection between what we just did and this polynomial here. So we have x plus 2 as our divisor, and then we're going to have our function that we're dividing, f of x, 2x cubed minus 3x squared plus 4x plus 2. All right, so essentially what you want to look for is this. What do I multiply this by to give me that? What would I have to multiply x by to give me 2x cubed? Well, that would be 2x squared. So we want to put that in our x squared column right there. 2x squared. If I was missing a term up here, like if that 4x wasn't there, I would put a 0x right there as a placeholder. Okay. Okay, now, remember what we did up here with the 1? When we got that 1 right there, we multiplied it to the 26. Well, we're going to do the same thing here. We're going to multiply the 2x squared to the x plus 2. Okay? When we do that, got to make sure you distribute. All right? So I'm going to have 2x squared, and you don't have to write this every time, but I'm just trying to show you in this example what's happening. 2x squared times x is 2x cubed. That's perfect. That's what we wanted. 2x squared times 2 is 4x squared. And now what we do is we subtract both of those. These will always cancel out if you did your math correctly. And then we combine these. Negative 7x squared. Feel free at any time to pause the video and rewind if you missed what happened there. Okay. Now, if you remember what we did next, we dropped that next number. So we dropped that 4x. And essentially, we start the whole process over again. What do we multiply x plus 2, or just focus on the x, actually. What do you multiply x by to give you the negative 7x squared? Well, we're going to have to multiply it by negative 7x. And then we multiply that negative 7x to that x plus 2. And we put what we get down here. So we get negative 7x squared. And we get negative 7x times 2 is 14x. It's actually negative 14x. But now we're going to subtract these, remember. So basically what happens is both these signs change. Okay, which is really what happened up here as well. We just changed both those positives to negative signs. Now we add these together. We combine them. Those cancel out. And we get 18x. There's a light at the end of the tunnel here, guys. Okay, because look, we only have one spot to fill there. So that means that we're in our last spot here. So what do you multiply the x by to get 18x? Oop, I forgot to drop my 2. I'm sorry. Let's go back and drop that 2 here. Okay, to get the 18x, we'd have to multiply that x by 18. So I'm going to have plus 18 right there. All right, multiply 18 to the x plus 2. Run out of colors here. 18x plus 36. Now we subtract these. So I have these cancel out. 2 and negative 36 is negative 34. All right, so here's what we found. Here's our summary statements right here. That's our remainder right there, the negative 34, okay? So we could say that that division is equal to, and which I rewrote again using the division symbol, is equal to my quotient, 2x squared minus 7x plus 18. And then what we'll do is we'll put, so I'm writing my first summary statement like we had right here. I already wrote the quotient. I already wrote that. Now I'm about to write the remainder over the divisor. Okay? So plus the remainder, which is negative 34. So actually I'm going to put minus here. Minus 34 over the x plus 2. That's the divisor. The other summary statement that we could write is that the original function f of x is equal to the product of that guy and that guy plus the remainder. So x plus 2 times 2x squared minus 7x plus 18. But we also have that remainder, so we have to add the remainder. Add negative 34 or minus 34. These are both true summary statements. So, I'd like you to notice something, if you haven't already. Some of you might have already noticed this. This number should look somewhat familiar, or this number should, that negative 34. If we go back to our second problem we did, it's the same number we got up there. In fact, if you notice, we were dividing that same function, or evaluating that same function at negative 2. Okay? Look at what the 0 of our divisor is down here. We divided by x plus 2. Its 0 is negative 2. So that negative 34 showed up in both spots. In other words, that remainder that we got is the same as what we get when we evaluate the function at the divisor 0, negative 2. That's not the only thing. Check this out. Recognize those numbers? How about now? That's pretty cool. In other words, we could have done long division by using synthetic division. That's right, division, not substitution. From now on, we're going to call this little process that we did division, synthetic division. Because essentially what we're doing when we put negative 2 in is we're dividing this by x plus 2 when we put negative 2 in, when we put that 0 in, or what's a possible 0 of the function. Okay? So, it's pretty amazing, clearly. All right? We're no longer going to use this process just for substitution. It is really a new division algorithm. Okay? But you can only use it in a certain, in a couple of cases. What you're dividing by, the divisor must be a linear binomial with a coefficient, a leading coefficient of 1. Okay, that's pretty much it. That's the rule. Okay, the quotient you get is always 1 degree less than the dividend that you started with. Okay, so remember, f of x is the dividend. So we started up here, if we were looking at this as division, we started with positive 2x cubed. When we drop below this line, this becomes 2x squared. So if you start with a cubic, when you drop below the line, okay, that was a cubic, this is now a quadratic. And we didn't know that when we were first doing this example 2 up here. But now we know. So this is 2x squared, and then we keep dropping degrees. 2x squared minus 7x plus 18. We can see it all right there. And then the remainder is that last number, that negative 34. Okay? So that's what this says right here. Going to the right in the quotient, each term is 1 less degree than the term to the left, just like standard form. The last number always represents the remainder. So that means that if the last number is 0, then the divisor, so if you don't get a remainder, think about when you do division with numbers. If you get no remainder, that means you found a factor. Okay? The divisor and the quotient are both factors. You can't get, this is such an important concept right here. Okay? The divisor and the quotient are both factors of the dividend of that original function. Here's 2 more. Math rocks. I mean, you can't deny the truth, right? All right, so we're going to do some division here. You can use any method, long division, synthetic division, or by using your knowledge of factors. Okay, we'll get to that in a second. So when we look at example 4, it says divide by x minus 2. Okay, that is a linear binomial whose coefficient is 1. So synthetic division is okay. Synthetic is okay. All right, I gotta write a little bit more legibly. This is gonna be like published on YouTube and whatnot. Synthetic is okay. Okay, so let's do it. Now here's the important thing. If you're dividing by x minus 2, what you put into this box, I call it the possible 0 of the function. Okay, maybe it's not a 0. I don't know. But if it is, the number I want to put in here is 2. Okay, so it's basically like you're saying x minus 2 equals 0, x equals 2. That's what I'm putting into the function as 2. I don't want to find out if it's a 0. If it's not, it's okay. So I put my 3, 1. Oh, there's no linear term, so I have to put a 0, and then negative 4. And then we do our synthetic division. Drop the 3, multiply, add them up, multiply, add them up, multiply, add them up. Okay? It's not a 0, because we did not get a 0 right there. In fact, what we just found out is f of 2 is 24. That's the remainder theorem. Okay? That when I do synthetic division, the number I get there, that's the remainder if I were to do actual division. Okay? But it tells us that 2 is not a 0, and it tells us that x minus 2 is not a factor. That's okay. We can still write a summary statement. We can write that the division, I'm just going to write our answer here to speed things up a little bit, would be 3x squared. Remember, this was cubed, so this guy here is squared. So we have 3x squared plus 7x plus 14 plus the remainder over the divisor. There's our answer. We can do it without long division. Okay, the next problem. We're not so lucky. Can't do synthetic division. We have to do long division. Okay, so I'm going to put in my division symbol here, my dividend, 2x cubed minus x squared plus 2x plus 25. And I'm dividing by x squared plus 2x plus 6. Okay, again, we can't do synthetic because that's not a binomial. It's not linear. Okay, it fails everything. Well, I suppose it has a leading coefficient of 1, but we can't. Okay? So the first thing we ask is, what do we multiply this by to get this? We'd have to multiply it by 2x. So where does that 2x go? It goes in this column. It's got to go in the same column as the term below it, the linear term. Okay? That's good. Look at, we only have one more step, you guys. So we multiply that 2x to the x squared plus 2x plus 6. We distribute that through. And we get 2x cubed plus 4x squared plus 12x. Okay, and you don't have to put those plus signs there if you don't want, because what we're going to do anyways is subtract everything. So if you do put the plus signs there, just make sure that you now put minus signs, because we're subtracting, remember, that whole thing. Just like you do in regular division. So now we subtract. Those cancel out. We get negative 5x squared. And 2 minus 12 is negative 10x. And then we drop the 25. All right, what do we multiply x squared by to get negative 5x squared? Negative 5. We multiply the negative 5 to that divisor, excuse me. Negative 5 times x squared is negative 5x squared minus 10x. And then negative 5 times 6 is negative 30. But now we've got to change all the signs. We're going to subtract. So this is going to become plus, 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 because we're essentially subtracting that. Now we can just combine them. Those cancel out. These happen to cancel out too. And we get a remainder of 55. Okay. This doesn't always happen where the middle term cancels out there, but it happens to do that here. So this is our remainder. Okay, so we know that I'm going to write this whole thing here. 2x cubed minus x squared plus 2x plus 25 divided by x squared plus 2x plus 6 is going to equal my quotient plus my remainder over my divisor. Doesn't get any more fun than this, you guys. All right, moving on. All right, x cubed minus 27. Ooh, notice something? That's the difference of cubes. X cubed minus 27 factors to x minus 3 because a is x, b is 3. It's what you would cube to get both those terms there. So I have a minus b. Remember, here's your difference of cubes. A cubed minus b cubed equals a minus b times a squared plus a times b plus b squared. So I've got a minus b taken care of right there. Now here's my a squared plus ab would be x times 3, or 3x. And then b squared would be plus 9. What a coincidence. Look at what we're dividing x cubed minus 27 by. By that same thing right there that I have right here. So I know if I divide x cubed minus 27 by this, I'll get left with that. So this is our answer. Okay? And we could write a whole statement like x cubed minus 27 divided by x squared plus 3x plus 9 equals x minus 3. There's our whole statement. All right, 2 more here. All right, because this is not a linear binomial, you can't do synthetic division. However, if you notice, this thing can be factored to x plus 2, x minus 2. So what I can do is take this thing and divide it twice using synthetic division, once with a negative 2 and once with a positive 2 from the zeros from those 2 binomials there. Okay? It's just like with numbers. If I wanted to take, 72 divided by, 50, no, let's do 36. Hopefully you know that that's 2. Okay, we know that equals 2. But I could divide 72 by 9 and then by 4, okay, because those are both 36 together. 72 divided by 9 is 8. 8 divided by 4 is also 2. Okay, so I can split this thing up if I want to. All right, it's the same idea here. So I'm going to take the negative 2 from this first one, and it doesn't matter what order you do this in. Doesn't matter. I'm just going to happen to do that negative 2 first. Okay, so I've got 2, 3, negative 8, and negative 12. And the 0 from that first binomial is negative 2. I'm going to drop it. Negative 4, negative 1, 2, negative 6, and 12. We get a 0. Now I'm going to do synthetic division on what I'm left with right there. So I'm just going to use that same line of numbers and do synthetic division right there. Now I'm essentially dividing 2x squared minus x minus 6 by x minus 2. Drop it, multiply, add them together, multiply, I can multiply, and we get a 0. So here's what we just found out. There's no remainder. Okay, there's no remainder. That 2x cubed plus 3x squared minus 8x minus 12 divided by is simply that guy right there. Now, what does that thing mean? Well, okay, think about this. This guy here was 2x cubed. When we dropped it down, that's 2x squared. When we dropped it down again, now that's 2x. We dropped down a degree every time, so that's 2x, and then plus 3 hanging out there, because that's a standard form, and they drop down a degree as we go from left to right. That's our answer. All right, last one, example 8. We can't do synthetic. This thing is not factorable, so we're going to have to go right to long division. I'm going to try that factoring thing again, though. I wonder if this thing can be factored. Let's try it. We know it's got to be x squared and x squared. 6, I can go with 2 and 3. I can go with 1 and 6. But they have to add to 7. So I'm thinking that the 1 and the 6 is what I want. Let's check it. We have x squared and 6x squared. That adds up to the 7x squared. This is what we want. And look, if we take that thing and we divide it by x squared plus 6, it's essentially going like this. And what we're left with is x squared plus 1.